The more information we have available, the greater the difficulty in comprehending and using that information. We need automatic ways of sifting through large amounts of data. The TIPSTER program is developing software to address these problems. For example, someone tracking joint ventures with foreign companies might want to search all financial text in an archive, a huge amount of data. A data detection system for retrieving relevant documents could narrow the number of messages to consider by selecting only those which are likely to be about a joint venture. But a data detection system can't tell you who, what, where, why, or other important information. Only that the information you want is likely to be found in the documents it selects. Data extraction systems like BBN's PLUM software can take this focused set of messages and find the companies and other objects of interest and relationships between them, producing output which can be used in reports, analyses, or databases. Under the TIPSTER program, 4 contractors, including BBN, designed data extraction systems for 2 languages, English and Japanese, and 2 domains, finding joint ventures in financial texts and finding information about microelectronic chip fabrication technology. These 4 applications were demonstrated and evaluated in a 2-year period.
For this demonstration, we will use BBN's PLUM software to illustrate our vision of how data extraction can help a user work more effectively through links back to the source text and intelligent editing. We'll show examples from 3 of the TIPSTER applications: English microelectronics, Japanese joint ventures, and English joint ventures. We begin with the English microelectronics application by selecting a message from the queue and starting the analysis. As each sentence is processed, PLUM highlights it to indicate its progress. When the analysis is complete, the results will be displayed at the bottom of the screen. In about the time it takes to read this short article, PLUM has already processed it completely and filled out its report. To do its analysis, PLUM looks up relevant words in its dictionary, groups words together into meaningful phrases, interprets each phrase, and combines the meanings to produce an analysis of the whole message. The results are then formatted and shown to the analyst. For the microelectronics domain, 20% of the articles were irrelevant, mentioning potato chips rather than computer chips, for example. PLUM's algorithms are language and domain independent. Our system is unique in its use of probabilistic algorithms for increased robustness and portability. Summary information is displayed without the full details. There is general information from the document header, then information about the microelectronics capability PLUM found in this text. How do we know this is a legitimate capability? If we click on the capability line, the text that provides the evidence for the capability is highlighted. We believe it is critical to be able to get back from the output to the original text easily and have the system provide justification for all its analyses. Now let's take a look at the full details for the manufacturer of this capability, Lam Research Corporation, by selecting the value and then clicking on the Details button to see the full information. If we click on the name field, all the references to Lam in the text are highlighted. Note that only the first reference contains the full names. Subsequent references are shortened forms, but PLUM is able to recognize that these are different ways of referring to the same company. Also notice that the text in the location slot has a special format. This comes from a gazetteer supplied by the government. The information in the location slot is more vague than necessary. Though PLUM correctly identified the state and country, the city of Fremont is also mentioned in the text. To correct this, we'll edit the information. The original value is displayed here. Pressing the button at the left rejects it. We could add the new value by typing it in, but instead we'll have PLUM help by selecting the text that contains the correct value, the word Fremont. Notice how PLUM normalizes the value by consulting the gazetteer. A person would have to do this by hand or by invoking another tool. Now let's turn to some Japanese articles about joint ventures. Since most viewers can read the Japanese, we'll save time by only showing the output. PLUM takes about a minute to process this message. This article describes a joint venture between National Micronetics and Sumitomo Special Metal. The underlying algorithms for both the English and Japanese systems are the same, though the knowledge bases are obviously different. The interface has the same look and feel, even though this is a different language and a different domain of interest. We can show all references to National Micronetics in the text. Though the labels on the extracted information here are in English for demonstration purposes, a user would probably want to work with them in Japanese, so we can switch between the two languages. Let's now turn to another English domain where the documents are about joint ventures. Unlike the microelectronics news, many of these texts are in uppercase, so there's no capitalization information to use to recognize proper names. Let's have PLUM begin analyzing this message to find any joint venture information in it. The text is converted to mixed case as it is processed. That makes it easier to read. As PLUM groups the words together into phrases, there are blanks in the highlighted text which indicate the phrase breaks. In interpreting relevant text, PLUM may construct a rich structure for the meaning. On the other hand, for irrelevant text, the representation of the meaning can be quite sparse. Our goal is to understand what we need to, but not fail to function if our understanding is incomplete. First, let's select the tie-up line to see the text that justifies the joint venture. Now let's look at the details of this tie-up. The different colors indicate PLUM's confidence in the accuracy of the information, where green tells the user, "Continue, the information is probably correct." Yellow means be cautious about the information, and red means you should definitely stop and review it, as it may not be correct. The output shows 5 companies involved in the tie-up. However, if we select a company in Japan and check the surrounding text, we see this is not one of the parents of the tie-up. In fact, PLUM did not recognize that it is a reference to the set of parent companies. We can press the cut button to remove the company. Suppose we wanted to use the entity we just removed to indicate the child company. We can select that slot and paste it in. Though this looks and feels like text editing, PLUM is actually doing more. It is moving all of the information about this object to the new slot. Because this is a correction done by the user, the confidence is increased to green. We can then go back to other entities and edit them to give them full confidence. There are other entities like Pertamina and Bank of Japan which PLUM chose not to attach to the joint venture, but they are made available as candidates for the editing process, should the user decide that they are correct.
We've shown how BBN's PLUM system can make it possible to automatically extract critical information from free text. One may use information extracted in this manner for report generation, database filling, smart indexing, and trend analysis. The performance of the system you've just seen is adequate for many applications, though human review is necessary where high accuracy is critical. The BBN PLUM system can process messages up to 20 times faster than a person can, allowing much more information to be extracted than by manual techniques alone. With our data extraction techniques, future users can begin to cope with information overload.